Welcome back. In our first video, we introduced stoichiometry. In this second video, we're going to solve question on stoichiometry, right? So this topic is stoichiometry. In the previous video, I have introduced some formulas we use in solving questions in the first part of stoichiometry, which I call the mole. Now, very quickly, in that video, I gave some formulas. Now, very quickly, let's use those formulas to solve these questions here. If you look at question 1, it says, how many grams of sodium sulfate, and here we are given the formula for sodium sulfate, are required to prepare 250 ml solution whose concentration is this M. This M here stands for, is pronounced as molar, which we call molar concentration or molarity. So without wasting time, I'm going to write down the parameters. So for question 1, in the question 1, we are given volume. So volume is 250 ml. Remember the unit of our volume, it is in milliliters. And then we are given concentration, C, and the concentration is what? 0.683 molar. So this is our concentration. And then we are asked to calculate the mass in gram. In our previous video, we said that number of mole is mass over molar mass. We equally said that number of mole is CV divided by, okay, let me write it both. Number of mole is CV divided by 1000. This formula is used when the volume is in milliliters or in cm cube. Now, using this formula to solve this question, we said a number of mole is this and number of mole is this. So we join this formula and this formula together. So we have mass over molar mass is equals to CV divided by what? 1000. Now, this is what we are looking for, which is mass. So we can make mass the subject of formula from here by cross multiplying. We will have that mass will be equals to molar mass multiplied by C multiplied by V, everything divided by 1000. Remember that I'm using the 1000 there because the volume in this question has been given to us in milliliters or cm cube. Had it been this volume is in dm cube or liters, we would have removed the 1000 from the formula. As simple as that. Now, we need to calculate the molar mass from the substance given. We are given the compound to be Na2SO4. And for such, to solve this, sodium is 23. So we have 2 times 23 plus, that's for sodium, this 2 times 23, relative atomic mass of sodium, plus sulfur is 32 plus 4 times 16. So if we do that, let me grab my calculator very quickly. All right. To do this now, we'll have it as, all right, so this is 46 plus 32 plus 64. So when we total that, so plus 46 plus 32. So we'll have 142 grams per mole. What I have solved for now is the what? The molar mass. So my molar mass is 142 grams per mole. Very quickly, putting everything here, we already have the concentration, see it there. We already have the volume in milliliters, see it there. So to get the mass, we just say mass is equals to, what is the molar mass in the question? 142 times, what is the concentration in the question? 0.683 multiplied by, what is the volume in the question now? 250. Then we divide everything by 1000. So that mass will be equals to, doing that, all right. We have it 142, okay, 0.683 multiplied by 250. Then we are having, okay, this divided by 1000 divided by 1000. We're having 24 points. Okay, we are having our final answer will be 24.2465. So we'll go back there in our option to check. We have it as, of course, option A is our answer. So this is the answer to this question. Up next, we need to solve the second question. And the second question now, we are asked, all right, please, you can pause the video and copy out the solution to question 1. So this is question 1, and now this is the solution to the question. Moving on now, let's quickly, like I said, you can easily pause this video and copy out the solution. So our answer to this question is option A. All right, moving on to question 2. Question 2 does not require much calculation. Look at it now. It says 1 mole of barium atoms contains what? In the first video, I defined the mole, but there is a concept of mole I did not tell you. My teacher normally uses this statement. He normally says that the mole, the word mole stands for dozen, can mean dozen. And when we say dozen, the word dozen means number 12. All right, so if we say a dozen of eggs, that means 12 eggs. Dozen of orange, that means 12 oranges, like that. The same way, 1 mole of a substance contains Avogadro number 6.02 times 10 to the power 23. But if you remember in the first video, I described something called the elemental entities, which are called atoms, molecules, moles, etc. Now, it is important to state that 1 mole, let me use this question now. 1 mole of barium atoms will contain this value, 6.02 times 10 to the power 23 atoms of barium. Pay attention to that statement. 1 mole of barium atoms contains 6.023 times 10 to the power 23 atoms of barium. So atoms to atoms. Had it been this question says 1 mole of barium molecule will contain what? Our answer would have been 1 mole of barium molecule contains 6.02 times 10 to the power 23 molecules of barium. All right. Had it been this question says 1 mole of barium particle contains what? We would have said 1 mole of barium particle contains 6.02 times 10 to the power 23 particles of barium. So particle to particle, molecule to molecule, atoms to atoms, like that. So that is exactly how we solve question on this one. So let's pick our answer very quickly. Our answer will be, all right, in the first case, we're having contains gram of this, no. This one says 6.02 times 10 to the power 23 ions of barium, no. This one says 6.02 times moles of barium, no. This one says 6.02 times 10 to the power 23 atoms of barium. So atoms to atoms, molecules to molecules, particles to particles. That is how we talk about it. We cannot say that 1 mole of barium ion contains 6.023 times 10 to the power 23 atoms of barium. That's wrong. So when we say molecules, we end it with molecules. We say particles, we end it with particles. So that is the solution to this question. If you want to check if what we are saying is correct, let's quickly look at the formula I gave for calculating the number of moles. All right, so in our previous video, I said there is a formula that says number of mole is equals to x divided by 6.02 times 10 to the power 23. So if the question says 1 mole, it then means the number of mole is what? 1 equals to what? X divided by this value, 6.02 times 10 to the power 23. Of course, if you cross multiply, you are going to get this value times 1. 6.02 times 10 to the power what? 23. Confirming what we picked. But they are trying to test you on the statement of the question, with the statement that is correct. And for such, we pick option D as our answer. All right, moving on beyond this one. We talked about, okay, let's quickly solve the number 3 question. The question says, how many moles of hydrogen gas are in 27 grams of hydrogen? All right. Of course, if you have not watched the first video on stoichiometry, do wait to do so, because somehow they laid foundation to all what I'm solving here. So the formulas I've been using to solve are right there in the first video. So do wait to watch that. And now let's solve this. I'm giving mass 27.0 grams. So mass. So for question 3, the mass in the question is what? 27.0 grams. And the question says I should calculate number of mole. Of course, number of mole is what? Mass divided by molar mass. This is the formula 1 from the first video. So we need to calculate the molar mass of hydrogen. Of course, hydrogen is written as H2. So I will have it as 2 times, what is the relative atomic mass of hydrogen in the question? 1.008. Of course, so that when I want to get the number of mole now, so this becomes my molar mass. This becomes 2.008. So that if I fix it there, number of moles. So let me come here, number of moles. What is the mass in the question? 27.0 grams divided by, what is the molar mass? 2 times 1.008 gram per mole. So that when gram cancel gram, we are left with mole then. So number of mole becomes, doing that very quickly, that's like dividing 27 by 2. And we should be having it in the option there. Okay, let's see. So we'll do it this way. 2 times. Okay, so this will be 27 divided by 2.016. So 27 by 2.016. We are having number of mole to be what? 13.392. This is our answer, and now go there to look for our answer in the option. Of course, we have 1.3 no, 134 no, and that's it, 13.4. That's our answer, option C. So this is how we solve questions using the formulas I dropped in the first video. Beyond this, now we'll move on now to topics like molarity and normality, as I promised. So very quickly, I'm going to rub off everything here and then show you formula for solving molarity. All right, so you can as well pause the video, copy out the questions and then the answers. Now let's move on to the bigger one now. So let's move on to bigger one. Let's move on to something very big. Very quickly. All right. Now, molarity. It is important I state this now, that molarity is different from molality, the one that have the L here instead of the R. But I'm going to treat this one now. The formulas I'm going to give you are formulas by way of shortcut that will give you answers to your questions with ease. All right. Now, what is molarity? We define molarity as the number of mole of solute per liters of solution. Right? I repeat that again. Molarity is defined, we usually represent it with capital letter M. Molarity is defined as the number of moles of solute per liters of solution. So that's what we call molarity. Please, it is important to state that molarity is represented with capital letter M, while molality is represented with small letter m. So quickly, what is the formula for molarity? We said that molarity, capital letter M, is equals to number of mole from the definition over the what? Liters of solution. So this is the formula for calculating molarity. We said that this N here stands for the number of moles of solute, while this L here stands for what? The liters of solution. It then means when we are solving questions on molarity, we will need to locate the volume of the solution and make sure it is in liters or dm cube. I have said it down with that number that 1 liter is what? 1 dm cube, which is the same thing as what? 1000 cm cube, which is the same thing as what? 1000 mil. All right. So this is it. 1 liter is 1 dm cube, which is 1000 cm cube, which is 1000 mil. It then means that liter and dm cube is the same. Now for shortcut for molarity. Now look at this formula here, shortcut. Why am I saying that this formula is a shortcut? Now let me write it first. By way of shortcut, we said that molarity, capital letter M, is equals to 1000 multiplied by M divided by V times W. So this is the formula we use when we want to get our answer faster and reliable. Now you may ask a question. Students may be asking, this one, is it not just dividing number of mole by liters? And this one is having so many parameters. Fine and good. Remember from the first video on stoichiometry, number of mole is mass over molar mass. It then means you need to solve for the number of moles by using mass over molar mass, and then coming back, converting the volume in the question to liters before you can now divide and get answer. So this is like two-way method of solving it, but this is just straightforward. It is important I tell you that in this shortcut formula, that the volume in this question, the volume in the question must be in milliliters or cm cube for you to put this 1000 here. Students, please take note. If this volume is in dm cube or liters, if the volume is in dm cube or liters, then remove the 1000. The formula will now be M, that's M over V times W. That will give you molarity when this volume is in dm cube or liter. But you will leave the 1000 there if this volume is in cm cube or milliliter, because the 1000 there is already there to convert that to dm cube. So this is the formula we use when we are solving questions on molarity. In this video, I'm going to drop the formulas so that in the next video, I will solve questions on them. What about this M that we are seeing here? This small letter M on top, the small letter M here stands for mass of solute. Mass of solute in grams. Mass of solute in grams. What about the V? I said that the V stands for volume of solution. Please, volume of solution, and I said it will be in what? Milliliter or cm cube for you to leave the 1000 in the formula. If the volume is in dm cube or liter, kindly remove this 1000. Then use mass divided by volume times W. Now, what about the W? The W stands for molecular weight. Molecular weight of solute. Molecular weight of solute. All right? Or you can say molar mass of the solute. Very, very important. We know that in stoichiometry of solution, we said that solute plus solvent usually gives us what? Solution. So it is important you note when we are saying solvent, solute, solution. If you want to take tea at home, you usually dissolve some Bonvita or Milo inside hot water. the hot water you are dissolving them in is the solvent, while those substances you are dissolving is the solute. Now, when two of them mix, the tea you are taking becomes solution. Now, it is important I tell you this. In exam condition, examiner usually make mistake of giving you this volume as the volume of the solvent or volume of solute. Please, whichever volume that is given to you, take it to be the volume in the question. So in some instances, I normally tell students that this volume here is the volume in the question. So any volume you see in the question, that will mean the volume of solution. But it is more accurate to state that the volume here is the volume of solution. So that's it for molarity. If you have these formulas now, be rest assured that you won't fail one question on molarity anymore. Let's look at the second concept. And that will be the end of this video, all right? So you can pause the video and copy out the formulas. So I will drop the second concept here, which is molality. All right? So I'm going to drop that one now, and that will be the end of this video. So that in the next video, we'll solve questions, and then I will complete the third concept, which is normality. All right. So I'm going to wipe this now. So let's look at it. Let's look at it here. There is second concept. So this is one. Second concept is molality. Molality is represented with small letter m. You can contrast that with the capital letter M that is in molarity. When we write something like this in chemistry, maybe 1.8 capital letter M, we pronounce this as 1.8 molar, which means the molarity of the solution is 1.8. All right? But when we write 1.8 small letter m, we usually call this one 1.8 molar. That's molar. So molality is measured in molar, while this one is measured in molar. I say this one is molar. All right? And equally, when we write 1.8 n, we call it 1.8 normal. 1.8 normal. So normality uses n, molality uses small letter m, and molarity uses capital letter M. Moving on now, let me quickly show you the formula we use in solving molality. So we said that molality, this one is Li, while that one is Ri. Take note. Molality is equals to number or more of solute over the kilograms of solvent. So the N in my formula stands for what? Number of moles of solute. While the kilogram, kgs, stands for what? Kilograms of what? Solvent. It is important to take note of this. Number of moles of solute divided by the kilograms of solvent will give us molality. There is a formula by way of shortcut. So by shortcut, so we have molality, small letter m, is equals to 1000 once again multiplied by mass of solute divided by capital letter M multiplied by W. So this is formula by way of shortcut we use when we want to solve questions on molality. All right? Once again, this M here stands for mass of solute. This capital letter M here stands for mass of solvent in grams. Mass of solvent in grams. Why this W here stands for what? Molecular weight of solute. So W in this place and this place remains the same. All right? It is important I tell you now that this mass of solvent, if it is in kilogram, remove this 1000. If this mass of solvent is in kilogram already, remove this 1000. The formula now changes to mass over this mass times W. That gives you your molality. All right. So do well to pause the video and copy out these formulas I have explained. In the next video, we are going to solve questions on this concept, molarity, molality. And then in the next video, we are going to introduce the third concept, which we call normality. All right, thanks. That is much we can take in this video. Remember to like, remember to subscribe, remember to share. Share this video to your class group, to different group chat, WhatsApp group chat, everywhere, so that your friends will benefit just as you have benefited. Remember that the YouTube channel name, I'll put it up here. Just search for Affinity CHN on YouTube. Then you are sure going to enjoy my videos. Thanks. See you in our next video.